This is your notes on student handout number 6 about box plots. A box plot is a display. This is your, in case you missed it, screencast about student handout number 6 over box plot. So a box plot displays data distribution using 5 key numbers. The difference between the first and third quartile is called the interquartile range. This is something you've probably heard before. All right, our 5 key numbers is your minimum, which is the smallest piece of data. Your first quartile, first quartile. A lot of times it's just designated Q1. Your median, which we've already learned how to do. Your third quartile. Sometimes just abbreviated Q3, and your maximum. Okay, let me sort of show you where all of these are. Your minimum is way down here, your smallest data point, minimum. Your largest data point is right here. That is your maximum. Okay, so we've done minimum, maximum. This line right here is the median. This side of the box is quartile 1, which is basically the median of the bottom half of the data from here to here. And this is quartile 3, which is basically the median of the top half of your data. Okay. What can I tell immediately just looking at what we labeled? Well, I can tell that my median for this data set is 15. I can tell that my maximum number is, it looks like maybe 18, that my minimum number looks like it's maybe 2-ish, that the first quartile is at maybe 12, and that the third quartile is maybe at 16 or 17, something like that. Okay, so we're just going to use these key indicators to help us figure out some data. Okay, now one of the other things I can tell from here is that almost all of my data, most of my data is right in here, and then I have some stuff that's more spread out down here. But if my median's way over here at 15, and here's quartile 1 and quartile 3, most of my data is in here, okay? From quartile 1 to quartile 3, half of your data sits in that box, okay? And then the other half is between quartile 3 and the max, or between quartile 1 and the minimum, okay? But this is half of your data in here. 50% of your data is right here in this box. All right, so let's just go straight into it and start familiarizing ourselves with all of these. It says the following data set represents the number of animal crackers in a snack size box. Okay, so first of all, we probably need to take these and order them from least to greatest. That would be helpful. Okay, so I have 1, 2, 3, 4, 5, 6, 7 numbers. 1, 2, 3, 4, 5, 6, 7. Okay, so I've ordered them from least to greatest. My minimum value is 34. My maximum value is 50. And then I am going to find the median next. To me, that's the easiest. Okay, so median, remember, is your middle number. So I'm going to start ticking off lowest, highest, next lowest, next highest, next lowest, next highest. The number in the middle of my list is 48. Okay, then I am going to take the lower half of my data to figure out what the first quartile is. So I'm going to look at my lower half. What's the median of my lower half? That's 45. Okay. I'm not going to use this because that's the median of the whole list. So 34, 45, 47. That's my lower half, and the middle number is 45. All right, then I'm going to do the same thing for the upper half of the data. The number in the middle of that half is 49. Okay. And then I am going to draw a box plot based on the numbers that are up here. Okay. 34 is going to be my minimum. 50 is going to be my maximum. My median is at 48. Quartile 3 is at 49. Quartile 1 is at 45. So here is my box. And sometimes you'll see box plots referred to as box and whisker plots because this part is the box and these two things are the whiskers. But anyway, box plot, box and whisker plot, whatever. Okay, so my minimum down here is 34. Maximum up here is 50. 45 is quartile 1. 49 is quartile 3. And the median of the whole list is right here, and it's 48. Okay. Number 2, the following data set represents the number of hours a small candle will burn. First of all, I find it helpful to take a second and put the numbers in order from least to greatest. So I'm going to do that. I'm going to pause while I do it. All right, I've got them listed from least to greatest. Originally, I didn't see the 14, so that goes right here in the middle of the list. I have, oh, and there's 2 9s. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data points. So let's make sure I have 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data points. Okay, so I've got them all. All right, my minimum is 7. My maximum is 19. I'm going to now find the median, which is the middle number in the whole list, by ticking off from the ends of the list. All right, it looks like my median is 11. Yep. All right, median 11. Okay, so I'm not going to use this 11. That's the median of the whole list. But now I'm going to look over here at the bottom half of my data, and I will get the median of that set. All right, so small, big, next smallest, next biggest. And I have 2 numbers in the middle. The average of those are both 9s. So the average of 9 is 9. So that is quartile 1. I'm going to do the same thing for over here, smallest, biggest, next smallest, next biggest. I have 2 numbers in the middle, but they're both 15, so that makes it pretty easy. 15. All right, then we are going to draw our box plot. My minimum goes at 7. My maximum is over here at 19. My median is right here. Quartile 3 is at 15. Quartile 1 is at 9. All right, so here's my box. And here are my sometimes called whiskers. Okay, so my minimum 7, maximum 19. Quartile 1 is at 9. Quartile 3 is at 15. The median of my data is at 11. And once again, my minimum is 7. My max is 19. Okay. All right, now they've already given you a box plot, and they want you to determine what these values are. So here we go. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I had to put in a couple little hash marks just to make it a little more obvious. Here we go. The minimum is right here, and it looks like it's at 11. My maximum is right here, and it looks like it's at 18. My median is the very middle, 14. Quartile 1, remember quartile 1 is basically the median of my bottom half of data, and it falls at 12. And then quartile 3 basically is the median of the upper half of the data, and it looks like it falls at 16.